Welcome back to this video lecture series on data structure and algorithms. Today we'll be starting with the introduction to tree data structure. So let's start. So what is tree data structure? Till now we have seen about the linear data structures like linked list, queues and stack. So tree is going to be the first non-linear data structure we'll be countering here, and this is called a non-linear data structure in comparison to linked list, queues and stack because they operate in a linear manner. A tree can be empty with no nodes, or it can be a structure with one node called the root node and zero or more number of subtrees. We will be recognizing ourselves with more these kind of terms in this later slide. So there are some common terms we will be using when we will be working with tree data structure. The very first and important term is root. So root is the node at the top of the tree. Here in this example you can see A is the root node of the tree. Then comes what is a parent node, what is a child node. Before telling this, let me take you on this concept of subtree. Well, subtree is nothing but in this diagram, this part DHI, this part can be called a subtree, or this part where the tree starts from B, this can also be called a subtree. The thing is that as we know, for a tree there is a characteristic that there will be a node and from there we will have successor nodes, right? So for A, the subtree will be the tree starting with node B, and for B the subtree will be the tree starting with node D. So this is a subtree. And parent node and child node nothing but is that suppose there is a node and there are some successor nodes to it, so those successor nodes will be called child nodes and this node will be called as the parent node of those child nodes. Siblings, well, the nodes which are child node to a parent node and lies in the same level called siblings. And lastly, the nodes which appear at the bottom of the tree, here H, I, J, F, G, these all are called the leaf nodes of a tree. So now after getting ourselves acquainted with the terms in tree, let us know how many types of tree are there. So we'll be starting with the very simple binary tree. Binary tree is most probably the most important one and mostly used form of tree. In this type of tree, a node can have 0 to at most 2 children node. These nodes are referred as left child node and right child node. In this diagram here, 10 is the root node of the binary tree and 6 is the left child node of 10 and 18 is the right child node of the 10. We can have only this node 10 and nothing else. Still we can call that node as a binary tree because it has this characteristic of it can have 0 to at most 2 children nodes. Next is the binary search tree. Binary search tree is a kind of an implementation of binary tree where the nodes or the structure of the tree follows a rule which is left child dot value is less than root value is less than right child value. In this diagram you can see the root node is 8 and the left child 3 is less than 8 and the right child 10 is greater than 10. If we observe more, we can see all those nodes which belong to the left subtree of this root node will be having values lesser than this root node value, and the nodes which will lie at the subtree or at the right hand side, they will have values greater than this root node. And we can have another type of tree which is called an AVL tree. AVL tree is a self-balancing binary search tree. In an AVL tree, the height of two child subtrees of a node may differ by at most 1. So we can see here there are two child subtrees of this node int, okay, and the height difference between them is here 0. So this is a self-balanced tree, this is a AVL tree. But if the scenario was like in this right part these 3 nodes were not there, this and this, only this node was there, so it would not be called an AVL tree. The operations like insertion and deletion have low complexity when we use AVL tree. Lastly, we will wrap this video up by knowing some of the applications of tree. There are some real life applications of this data structure, like folders in operating system, the way they are stored or the way they are operated on operating system. Then there is HTML document object model or DOM, and we can also use the tree data structure in network routing. Now coming to the data structure oriented implementation details, we can use the tree data structure and manipulate hierarchical data. We can manipulate sorted list of data, and as this is a non-linear data structure, so searching for some information becomes very easy, as we can search it by keeping as a key and by not visiting every other node. So this is an advantage of using tree over other linear data structures. Thank you for watching this video and staying with us. See you next time.